conjugate root theorem. This is a pretty difficult problem that I asked you to do on the assignment. I'm going to go through it so you could do it and have it done on the assignment. So that's what I would do. So it's problem number 15 on the worksheet from yesterday. So we're given if the square root of 5 and 3 are roots, we're asked to find the polynomial. So the question is, first of all, we learned yesterday the conjugate root theorem. The conjugate root theorem says if you have an imaginary root or an irrational root, then its conjugate is also a root. So we have right now x is equal to the square root of 5, and we have x is equal to 3. Is there any other roots? Good. X is equal to negative square roots of 5. Because if this is a root, it's irrational. Try typing it in your calculator. You hit enter. If you try to put it back into a fraction, it won't. So irrational means can't be written as a fraction. So its conjugate is also a root. All right. And then does that work with 3? Does it work with 3? No. Numbers, fractions, they do not have conjugate roots. Okay, so then from here, guys, you would bring things over to the other side to get it set equal to 0. I'm going to actually write this up here so I have room. So you'd say x is also equal to negative square roots of 5, x is equal to 3. Now, we would bring things over the correct way. So I would subtract square roots of 5 from both sides. So we would get x minus the square root of 5 is equal to 0. Then here we would add square roots of 5 to both sides. So we would have x plus the square root of 5 is equal to 0. And then we would subtract 3 from both sides. So we would have x minus 3 is equal to 0. Now, since they're all set equal to 0, those are our factors, linear factors. We can bring them together and multiply them out. So x minus the square root of, oops, I was going to write 15, but it's 5. X minus the square root of 5 times by x plus the square root of 5 times x minus 3. And then we would go through and distribute these things. Now, once again, take my suggestion, multiply the conjugates together first, because a lot of stuff's going to cancel out. X times x is x squared. X times the square root of 5 is positive x square roots of 5. And then we have negative square roots of 5 times x. So that will be negative x square roots of 5. And then negative, this is where it's tricky kind of, negative square roots of 5 times positive square roots of 5. Since they're good. So you got the square root of 25, and that is 5. So it's minus 5. Now combine like terms, so we'll have x squared. Look, our middle terms cancel out. So we have x squared minus 5. And then from there you would multiply in x minus 3. So we would have x times x squared, which is x cubed, x times negative 5, which is negative 5x, then negative 3 times x squared, which is negative 3x squared, and then negative 3 times negative 5, which is positive 15. Then you just make sure it's in standard form, not quite. So we have x cubed, then minus 3x squared, minus 5x, and then plus 15. So that would be our final answer. Okay. Are we all okay with that, what we learned yesterday? So, okay, awesome. Any questions on that? Okay, let's just get started with the new stuff then. All right. Now today's B-Day, so that assignment's not due till tomorrow. You can watch this video, watch the video from yesterday. Okay, so today we're going to be graphing quadratics. But today we're going to be graphing quadratics not in standard form, but in vertex form, which is actually way easier than graphing something in standard form. So remember, quadratics means degree 2. We have graphed quadratics in here, though. Given f of x is equal to ax squared plus bx plus c, we were graphing them. We found the zeros, right? We were able to find the zeros using the quadratic formula. We could find the minimum using our calculator, right? Minimum or maximum, we were able to graph. Well, today we're going to learn how to graph these in vertex form. And it's actually way easier. And that's what we're going to be doing. So this is what vertex form looks like. Now you need to understand these two things are equal. They're just different forms. Apples and applesauce. Well, applesauce is a lot easier to graph than in standard form. So that's what we're going to do. All right. Okay, so this is where you'll want to start writing. So graphing in vertex form. It has this equal to x minus h in parentheses squared plus k. Now, right inside here, what's added with our x is our shift left and right. Now, you always go the opposite of what's added with our x, right? So you go the opposite. And then this is our shift up and down. So this is going to stay the same. This is what's added on the outside of the parentheses. It'll be our shift up and down, and that will stay the same. So get that down, and then we'll continue. I'll make a point here. All right, so look at this, guys. Remember that when we were graphing rational functions, we had something like this, 1 over x minus h plus k. Now look, what's added with the x was our shift left and right. Isn't that the same as what we're doing today? Interesting. And then what's added on the outside is our shift up and down. Isn't that the same as our quadratic today? So guys, shifting of functions works the same for all. So all these shifting of functions, it's going to work the same way. Whatever's added with x will be your shift left and right. Look in both cases, that was true. You always shift the opposite of the sign. And then whatever added on the outside of the parentheses, not with the x, will be your shift up and down. And you always stay with the sign. So just make that relation, that connection. Hopefully that'll help you with the future problems we're going to do in coming up next few lessons. Are we okay if I go on to the next slide? This is just to recall that it does work the same way. Okay, so now today we're going to be more advanced. Guess what? You've learned how to graph quadratics in secondary 2. Today we're going to get more advanced because we're going to have an acceleration greater than 1. So probably in secondary 2 they only had to graph things with an acceleration that's 1. But today we're going to be doing accelerations greater than 1. So we're going to be adding on our knowledge, doing more advanced problems today. So this is the actual form here. F of x is equal to a times x minus h squared plus k. So we're going to have to take in consideration our acceleration today. What's multiplied in front of x minus h squared. Now, if our acceleration is positive, then this is this little trick I'm going to show you to graph these pretty quickly. If it's positive, you'll go over 1. And then because it's positive, you go up. And then there's this 1, 3, 5 pattern that happens with quadratics. So you'll see what I mean in a second, but the 1, 3, 5, 7 pattern happens with quadratics. So if it's positive, you always go over 1, and then you'll go up 1, over 1, up 3, over 1, up 5, over 1, up 7. And then you'll multiply that to a, the 1, 3, 5, 7, and you can graph it. So once again, this isn't going to probably make sense until you see us practice it, but get it down. If it's negative, if a is negative, you still go over 1. You always go over 1 both ways. And then instead of going up, you're going to go down 1, over 1, down 3, over 1, down 5, over 1, down 7. 1, 3, 5, 7. But you do have to multiply 1, 3, 5, 7 to a. So keep that in mind. Get that down. 1, 3, 5, 7. It's a pattern that happens with quadratics with graphing. It makes graphing pretty easy, especially if it's in Vertex form. So we'll practice that. Now notice we always go over 1, even if it's positive or negative. We're always going to be going over 1 both ways to form our u's. So that's just how that's going to work. If we go up or down, depends on if it's positive or negative. And then it always works in a 3, 5, 7 pattern. Okay. Am I okay to go? Anybody need another second on this slide? Okay, here we go. Let's just practice. Oh, okay, let's practice first with the parent function. So remember that parent functions, guys, mean the non-shifted, most basic function. So the parent function of a non-shifted quadratic is f of x is equal to x squared. Does everybody understand that? Okay, so let's graph that. Now notice this has no shift left and right, no shift up and down. So our vertex is at 0, 0. It's not been shifted at all. So are you all okay with that? Does that make sense? All right, so now our acceleration, there's technically a 1. I'm going to do it in a different color. There's technically a 1 in front of x squared. So our acceleration is 1. Now, no matter what, we always go over 1. And since it's positive 1, we're going to be going up. So since it's positive 1, we're going to be going up. So now, also, if we take 1, 3, 5, we know that that's our pattern 1, 3, 5, 7 pattern. If we multiply that by 1, our acceleration, each of those things, we still get 1, 3, 5, and 7, correct? If we multiply 1, 3, 5, and 7 by 1, do we just get 1, 3, 5, 7? Yes. So now we'll do our little pattern. You go over 1, up 1, put a point. Go over 1, up 1, 2, 3. Over 1, up 1, 2, 3, 4, 5. Then over 1, up 7. I only need to go up 5. That's going to run off my graph. So I got to do it on both sides. Over 1, up 1. I already went up 1. So from the bottom, I like to just do one side at a time. So over 1, up 1. Over 1, up 1, 2, 3. Over 1, up 1, 2, 3, 4, 5. Do you guys see how the 1, 3, 5 pattern kind of works? Over 1, up 1. Over 1, up 3. Over 1, up 5. There's my quadratic. That wasn't too bad, was it? That's our non-shifted parent function. That one wasn't too bad, was it? Okay, did it make sense? Okay, let's do another one. Here are the steps. If you want to write down the steps to graphing a quadratic, but we just practice the steps. So the first thing you'll do is plot the shifted vertex. You'll look, where's my shift left and right? Where's my shift up and down? Plot the vertex. The vertex is going to be at h, comma, k. So it's going to be at, we always go the opposite of the sign, so h, comma, k. So that'll be our shift left and right. This will be our shift up and down. Once you've plotted the new vertex, you'll move on to the second step. You'll plot the acceleration. If it's positive, you always go over 1 and then up, 1, 3, 5, 7 times by a. So you will have to times it by a. And then you'll go over 1. If it's negative, you'll go over 1, down 1, 3, 5, 7 times by our a value. Okay, so those are the steps. So if you want to take a picture of that, you can. If you want to take a picture of that, that's what we used to do in my college classes because it was easier than writing it down. But it's up to you. If you want to hurry and write it down, that's fine. All right. Here we go. Let's practice. Are you watching? Here we go. All right, so here's our first problem. F of x is equal to x minus 5 squared. We know it's quadratic because of the square, minus 2. So first of all, it's in vertex form, right? So we'll go ahead and graph it. Now, find our new vertex. That's our first step, is to find the vertex. So let's look at our shift left and right and look at our shift up and down. So are we shifting left or right? Left or right? Do you do the opposite of what's inside the parentheses? Yes. So we're going to be going right. 5. Is everybody following me? Because I'm not so sure if you are. Right 5. Does everybody understand that? Yes. And then we're going to go down 2. The sign stays the same with what's added on the outside. So start at the origin, go right 5, right 1, 2, 3, 4, 5, down 1, 2. There's my new vertex. So my vertex is at, guys, 5, comma 2. Does everybody, negative 2. 5, comma negative 2. Does everybody see how my vertex is at over 5, down 2? Are you all following? Okay, we're almost done. Now we just have to plot the acceleration. Now, no matter what, you go over 1. Are we going to be going up? Well, what's my a value? What's my a value? 1. So I'm going to write that in there. Okay, is that a positive 1? So we're going to be going up. So we are going to be going up, and then I write it down like this. 1, 3, 5. I'm not going to do 7 because it's going to go off the graph. So 1, 3, 5. Now multiply those each by your a value. So times 1, times 1, times 1, which is 1, 3, 5. So we have a 1, 3, 5. That's what we're going over. So start at your origin. We're going over. I'm going to do the right side first. You have to do both sides. We're going over 1, up 1. Over 1, up 1. Did everybody follow? Just did that one. Now we're going over 1, up 3. So from here, I'm going to go over 1, up 1, 2, 3. Over 1, up 1, 2, 3. Just took care of that one. We always go over 1. We're going up. And now what are we going to go up? 5. So now from here, I'm going over 1, up 1, 2, 3, 4, 5. Over 1, up 1, 2, 3, 4, and 5. And I draw it in. Questions? Yeah.
So you know it's right or left by the sign, right?
Yeah. Remember, inside the parentheses is always our shift left and right. and you go the opposite.
So if it's negative, you go to the right, and if it's plus 2.
Right. And then on the outside, we go with the sign. Does that make sense?
Yeah.
Okay. Let's do another one. All right, so given this one, f of x is equal to 2 times x minus 1 squared plus 2. The first thing we have to do is determine our shift left and right and determine our shift up and down. What's my shift left and right? Right, 1, and then we're going up 2. The sign stays the same with what's added on the outside of the parentheses. Is everybody okay with that? Okay, so I'm going to go right 1 and up 1, 2.
What about the square? Does that matter?
That means it's quadratic, right? That's why we know we can graph quadratics like this. That makes it quadratic. Does that make sense? Or do you mean this too?
I was just thinking like maybe with the square would be 2. So,
What would be 2? No, it wouldn't be. Because we would rewrite it. We don't just square that. And even if 1 squared is positive 1, right? Okay, so what's our vertex at what point? Look. 1, comma, 2. All right. So now let's go ahead and plot our acceleration. Well, first of all, is it positive or negative? So we're going to be going up. It's positive, so we're going to be going up. Now we know that we have a 1, 3, 5 pattern because it's a quadratic. Now you have to multiply those by your a value, which is 2, 2, 2. So 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. So now we're actually going to be going over 1 up 2, over 1 up 6, over 1 up 10. So let's start. Yep, times it by your a value.
Oh, no, I got you.
Nope, no, you're not. You're good. Okay, so from here, I'm going over 1 up 2, over 1 up 1, 2. I'm doing it on this side. I'm also going to do it on this side, over 1 up 1, 2. I just took care of that. Now I'm going to go over 1 up 6. So from here, I'm going over 1 up 1, 2, 3, 4, 5, 6. Over 1 up 1, 2, 3, 4, 5, and 6. Now notice, that was pretty like squished together, right? Well, that will happen. The reason that happened is because this 2 was multiplied, the acceleration was much larger, so it compresses your parabola. But the way we do it, we're taking care of the compressing by the way we're doing it. But just notice, this 2 means the acceleration goes way quicker, which will pull your graph in. Does that make sense? Your acceleration is getting larger quicker. So do you see how it's getting larger quicker? So it squishes your parabola in. So it's called a compress. So, questions on how I did that? Okay. Let's do number 16 together. On the worksheet on the back, number 16. So we're given f of x is equal to negative 1/4 times x minus 1 squared plus 4. Now once again, that squared there just means we know it's a quadratic. So we know we're going to be graphing quadratic. It's in vertex form. So we'll go through this. All right, first the thing you do is determine your shift left and right. Where are we going? Right 1. Right 1, and then up 4. So what's my vertex going to be at? 1, comma 4. So over 1, right 1, up 1, 2, 3, and 4. Does everybody feel okay with that? All right. So now we're going to be always going over 1, but it just depends if we go up or down depending on the sign. Depending on the sign. So since it's a negative, we're going to be going down. Very good. It's going to take our smiley face and flip it upside down. So we're going to be going down. All right. Now we know that parabolas have a 1, 3, 5 pattern. 1, 3, 5, 7. 7 is going to go off the graph though. But we have to multiply that by your a value. Not carrying through the negative. The down part was the negative. So 1 times 1/4. 3 times 1/4. 5 times 1/4. So calculators. Do a decimal. Graphing is way easier with decimals. So you'll type 1 times 1/4, which is 1/4, but let's do the decimal because it's easier to graph a decimal. So 0.25, right? All right, 3 times 1/4, so you'll do 3 times, put it in parentheses, 1 divided by 4, and you get 0.75, so not quite 1. And then 5 times 1/4 is 1.25. All right, so now we know we're going to be going over 1, down these things. So from here, I'm going over 1, down 0.25. So I'm barely going down, right? So over 1, down 0.25, about right there. Do it on both sides. Over 1, down 0.25. So I just took care of that one. Now we're going to go over 1, down 0.75, so not quite 1, but a little bit, almost 1. So I'm from that blue point, you're going over 1, down 0.75, so not quite 1. It's going to actually kind of land right there. So down over 1, down 0.75. So it'll land kind of right there due to the fact that it's shifted down. All right, and then we'll go over 1, down 1.25. Over 1, down 1.25. So I'm going over 1, down 1.25, over 1, down 1.25, and now I can draw it. Now notice this is kind of a stretched out parabola. It's kind of like chubby looking, right? Kind of opens up wider. Now that will happen if you're multiplying by anything smaller than 1 out here, because so this is a fraction. If you're multiplying by a fraction, it's going to stretch it out because the acceleration doesn't happen so quickly. It's not such a deep acceleration. It's more spread out, slower happening. Does that make sense? The negative flips it upside down to a frowny face, right? Okay. Did everybody understand how to do that one? Okay. All right. I think you guys did it. I don't think we need another example unless you do. How many of you feel ready to try it?
That's easy money.
You ready to try it? Okay. Do problems 15 through 20. Go. We didn't finish the axis of symmetry. So the axis of symmetry is your x value where your shifted parabola happened. So this is at positive 5. So it will make you draw that in. This is my axis of symmetry because it's symmetric, perfectly symmetric around that line. Does everybody see that? So it'll be your x value of your shifted parabola. So look right here. What's my x value? 1. So my axis of symmetry will be at 1. Now notice when I draw that in, it's perfectly symmetric around that line. And then once again, this one was at 1. So at 1, I draw my axis of symmetry. It's perfectly symmetric about that line. So there's your x value of your shifted parabola. Okay, continue. All right. So now we have to learn how to put something from standard form to vertex form. So how many of you, raise your hand, think that graphing something in vertex form was 10 times easier than graphing it not in vertex form? Just curious. Some people, do you think it's, how many of you think it's a little bit harder? Same? No one cares to answer. So let's have the vote again. Just curious, how many of you think it's easier? Participate in my class. You guys are freaking boring. How many of you think it's easier to graph things in standard form? You don't have a preference, okay? How many of you think it's better to graph it in vertex form? Okay, look at that. You guys know how to participate. All right, so we're going to take something from standard form and put it in vertex form. Now, this is a process, though. It's a process. It's not just going to be an easy thing. You have to do lots of stuff to get it from standard form to vertex form correctly. Okay, so you do it by the method of completing the square. So it's a method called completing the square. And this is how you'll complete the square. So once again, vertex, standard form and vertex form are equal. They're just different forms. But we're going to take something from standard form and change it to vertex form. Okay, here's the steps. You'll want to probably just take a picture of this because there's a lot of steps. And we don't have time to wait for you to write it down. So just take a picture of that real quick. so that you can have it and look at it on your phone, because it's just too long. So guys, as you take a picture, listen. So it's in standard form, ax squared plus bx plus c. The first thing you have to do is make sure it's in standard form and set equal to 0. Then from there, you're going to, first of all, well, I already said that. Put it in standard form, make sure that it's equal to 0. Then second, you have to, this is so important, the most important thing. This is the most forgot thing. You have to make sure a, the value in front of x squared is equal to 1. So you might have to factor out something. If a is something other than positive 1, you need to factor it out. Then once you've factored it out, your a is now 1. You'll leave it off to the side for a minute, the a that you factored out, and you'll continue. So then you're going to complete the square. You're going to take your b value. You'll divide it by 2, and then you'll square it. That's your square. So you're going to insert, at fourth step, you're going to insert that square, you're going to insert the square as a fancy 0. Because you can't just change the problem. So you can't just add something without fixing it. So I'll show you what I mean by a fancy 0 in just a second. So you're going to insert your square as a fancy 0 into the equation. Then you're going to put it, and you have to put it in the correct place. And then you're going to factor and combine. So look right here. Notice I added a square, subtracted a square. What's plus square minus square equal to? 0, right? 0. So we're adding a fancy 0 into our equation. Now notice, this is really important. Notice I inserted the square right after bx. Does everybody see how right after bx I added my square? Then I subtract my square, and then I have my plus c. So you've got to insert this into the correct place. It's after bx. Add your square, subtract your square, plus c is equal to 0. Then what you'll do is group your first 3 terms, and you will factor. Now guess what? There's a trick. You won't even have to factor. You just look back into the inside of here, and that's what you know it's going to factor to be twice. So I'll show you what I mean in just a second. I know right now it's all just words. So you're going to factor the first 3 terms, and then you're going to add the last 2 terms. And you're done. And you're done. A lot of steps. It's not as bad as it seems right now. It's not as bad as it seems. Hopefully. All right. Does everybody got the picture? Okay, here we go. Are you ready? All right, so we're going to do number 1 together. Everybody, number 1. If you want to work on it on the worksheet, that's fine. You're going to probably need more room, though, to be honest. I'm sorry. I apologize that there's not more room on there. I will do better in the future to leave more room. Okay, so we're gonna write this thing that's in standard form to vertex form. Notice it's in standard form because it's in ax squared plus bx plus c. All right, so somebody tell me, what is my first step? Participate so we can get through this lesson 10 times quicker. Make sure it's equal to 0. So we have x squared plus 16x plus 71. We'll say it's equal to 0. It is in standard form. We can set it equal to 0. All right. What's my second step to make sure that a is equal to positive 1? Is a equal to positive 1 in this one? Yes. So we can just go. So now we're going to complete the square. So what you do is you take your b value, divide it by 2, and then square it. So what is my b value in this problem? 16. Not 16x, it's 16, right? B is the value in front of x. So we're going to take 16 divided by 2. I'm going to show all my work. If you show your work, you're going to help yourself. So I'm going to show all my work. So 16 divided by 2 squared. We'll keep showing, don't just calculate it. You're going to use this work. 16 divided by 2 is positive 8, right? So 8 squared. 8 squared is equal to 64. That's our square. That's what we're going to insert into our equation as a fancy 0 in the correct spot. So remember, in the correct spot would be after that 16, after that b, after that bx. So I'm going to rewrite this again. X squared plus 16x. Now I'm going to insert, I'm going to do it in a different color. I'm going to insert my square, and you always add it. Add 64. But if you add 64, you've got to subtract 64, because we can only add a fancy 0. Did everybody get up to there? And then we won't forget about our plus 71. Can everybody see that right here is my fancy 0? All right, then from here, we're almost done. Literally, the steps look harder than it really is. We're almost done. Group the first three terms and factor them. We're not even going to have to factor because there's a trick. Everybody look at the trick. So this is what we're factoring. Now here's the trick. You could factor it. We know how to factor quadratics, right? Or because of how this is set up, you can actually take your eyeballs, look back to what was inside before you squared it. Inside the parentheses before you squared it, so not 64, but in the parentheses before you squared it, we got positive 8, right? So this is going to factor to be x plus, since it's positive, 8 squared. Plus 8 happens twice. So that's a trick to use. Look back what was inside, yeah. Yes. Yeah, you can, yeah, because you'll do the same process. You always look back to see what was inside the parentheses before you squared it, and that's what it will factor to be twice. Yeah. Any questions? Wasn't that quicker than actually factoring it? Yeah. All right, and then you're going to add up these two terms. Add them up. Make sure you carry that sign through. That was negative 64 plus 71, which is positive 7. Does everybody see that I'm just adding those together? Plus 7. Well, look at that. There's my function in Vertex form. Now, once again, if I was to take that and split it apart and write it as x plus 8 times x plus 8 and multiply it out and add 7, I'd end up back up here. This is the same thing as this, just in a different form. Cool, right? Okay, now keep in mind, I'm going to let you do a problem now, but you have to be careful. Because if this would have been negative 16x, you would have done negative 16 divided by 2, and that would have been negative 8. Negative 8 squared is still positive 64, right? But when you factored it, it would have been x minus 8 squared. Does that make sense? Okay, awesome. Practice problem number 2. Equal to 1, so let's, not more steps, but kind of. The process is still the same. All right, so we're going to do number 3 together. So number 3 is y is equal to negative x squared minus 14x minus 59. First thing you have to do, very important, make sure it's in standard form and set equal to 0. Negative x squared minus 14x minus 59 is equal to 0. It's in standard form. Second, most important thing, you have to make sure your a value is positive 1. If you do completing the square and you pretend like it was positive 1 and it wasn't, you're going to have the wrong answer, I promise. Does everybody see how in this one our a is actually negative 1? That's a problem. That's a problem. We can't start completing the square. So before we complete the square, we're going to factor out negative 1. So we're going to write it. When we factor it out, you have to write it on the outside of the parentheses. So I'm going to factor out negative 1. Now remember, if you factor out negative 1, when you factor something out, what you did was divided each term by that thing. So let's go through and see what we have left in our parentheses. Negative x squared divided by negative 1 is positive x squared. Negative 14x divided by negative 1 is positive 14x. And then positive 59. Now you have to keep that negative 1 out in front. We're going to ignore it for a second. And we're going to complete the square with the inside piece. But we have to remember in our final answer that it's there. For right now, I'm ignoring negative 1. Now I have 1 is positive. A is positive 1. So now we'll focus on this part and complete the square. So this is where we go out to the side. We take b divided by 2. So it's positive 14 divided by 2. And we'll square it. Now remember, showing your work helps you because then you can factor it quicker. So 14 divided by 2 is 7. So we're going to have 7 squared. Are you all caught up? Okay, awesome. 7 squared is 49. So we're inserting our square into our equation in the correct spot. Now remember, it has to go after bx, so we're going to insert it right there as a fancy 0. So we will have x squared plus 14x, then we add our square, so plus 49, then we subtract our square, minus 49, so that we're only inserting a fancy 0. And then we won't forget about our plus 59. And that's equal to 0. Okay, catch up to me and then we'll continue. Now we group the first 3 terms and factor them. Well, we don't even have to really know how to factor. even though we would know how, we would say what multiplies to be a times c, adds up to be b, but we could use our trick. You look back to what was inside the parentheses before you squared it, and we had a positive 7. So this is going to factor to be x plus 7 squared. And then we're going to combine negative 49 plus 59, which is positive 10. And we're not quite done. Almost. What did we have up here? Negative 1. So we have negative 1 times that stuff. Okay? Now, what they're going to do is we want it to stay in vertex form. So we're going to multiply each of these things by negative 1. So we'll have negative 1 times x plus 7 squared. Now, we're not going to distribute negative 1 in there because we want to keep it in vertex form. That is vertex form. But then we also have negative 1 times positive 10, which is negative 10. So this would be in vertex form. Questions on that one? Is everybody okay with me distributing that negative 1 in very last? Okay, positive 10 times negative 1 is negative 10. Okay, questions? Okay, so I'm going to have you practice problem number 4. I'll leave this up. So we're doing practice problem number 4. Now look, what are we going to be factoring out first of all? A 2. So you'll do the same thing we did. It was negative 1. It'll be a 2. You'll distribute that 2 in last. I'll leave this up, and as you do number 4, you can look at it. Number 6, y squared is equal to x squared plus 4x. First, important, is it in standard form and set equal to 0? It is in standard form, we'll set it equal to 0. Is second most important thing, a lot of you forgot to do this, check to make sure your a value is positive 1. Is it in this one? So we can just start, okay? So now we can just start, but if it wasn't, we would factor it out and forget about it till the end. All right, so we're going to go ahead and do this. You take your b value, which is positive 4, you divide it by 2, and then square it. It's beneficial to show our work because we use it for a trick. 4 divided by 2 is 2. So we have 2 squared, which is 4. That's our square, our fancy square. Now we're inserting it in after bx every time, right? So after the 4x right here is where we're inserting it. So we're going to have x squared plus 4x. Then we're inserting plus 4. Now, can I just add 4 and stop? I got to subtract 4, right? Because I can only really insert a fancy 0, which is equal to 0, because there's nothing else added. Then you group the first 3 terms and factor. Let's use our trick. We're not actually factoring by using the trick, but that's okay. We learned the little trick. Back inside was positive 2. So this is going to factor to be x plus 2. Don't forget the squared part. And then add up negative 4 plus whatever, so it's negative 4. Very good. Now we are done with this one, but if we weren't done, if we had factored out a value for a, we would then multiply it to each thing. But you wouldn't multiply it in right here, you just leave it. But this is our final answer since we didn't factor anything out. All right, any questions on that? Okay, awesome. You guys are doing great. So you're going to do, this is what's due, problems 5, 7, and 13, and then any problem we did together. So right now I would do 5, 7, and 13, and then make sure you've done the whole back page, graphing, and that's what we're going to do.